In this problem, we look at the combustion of a hydrocarbon. In general, the hydrocarbon is CXHYOZ. We do not know X, Y, and Z, which would give us the empirical formula. In this particular case, we know that there are 0.4647 grams of that compound, and a combustion reaction in excess oxygen is going to produce carbon dioxide and water, and we show the quantities produced there. In general, the way you solve this problem is to figure out how many grams of carbon were produced. That must come from the number of grams of carbon that reacted. Let's look and see what that is. We have 0.8635 grams of CO2. If we calculate the molar mass, we see that there are 44.01 grams of CO2 per mole of CO2. The grams of CO2 cancel out. If we look at carbon dioxide, there is 1 mole of carbon for every mole of carbon dioxide. Now we have the moles of carbon in the products, but we need the number of grams. There are 12 grams of carbon per mole of carbon. That will tell us the number of grams of carbon that are in the product. We do a similar thing for hydrogen, knowing that it was produced out of the hydrocarbon. We only know, though, that we have 0.1767 grams of water, so we have to look and get that to determine how much actual hydrogen was in that. The molar mass of water is 18.016. Now we would have the moles of water. In looking at this, there are 2 moles of hydrogen for every mole of water. We're not dealing with H2O now, but just H. And the molar mass of just hydrogen itself, not a mole of the compound, but just a mole of the gas. Our next step is to find out how much oxygen we have here. Sometimes you can do this by inspection, but you can't do that here. It's too complicated to actually look at this problem and do that. But we do know that if we knew the total amount of product we had, it contains only carbon, hydrogen, and oxygen. So if we subtract the mass of the carbon and subtract the mass of the hydrogen, we would have the mass of the oxygen. When we do that, that tells us that we have 0.211 grams of oxygen. We have 0.236 grams of carbon, 0.1977 grams of hydrogen, 0.211 grams of oxygen. We know now in the compound CXHYOZ, that's how many grams we have. What we want in X, Y, and Z is not the grams, but the number of moles. So we have to divide each of those terms by the number of grams per mole. We have that many grams of carbon. We divide by 12.01 grams per mole. And so we have 0.019 moles of carbon. .1977 grams of hydrogen divided by 1.008 grams per mole. Gives us 0.01961 grams of hydrogen. Doing a similar thing for oxygen, we have 0.132 moles of oxygen. So, we can write our formula then. H 0.019, C 0.019, O 0.0132. But we can't have a formula like that with numbers at the bottom that are not integers, so we had to try to convert this to integers. Divide by the smallest number. The smallest number, of course, is 0.019. That would give you a C1, an H1, and a 0 for the oxygen of 0.67. In order to get that to a whole number, we have to multiply everything by 3, and we have C3H3O2, and that becomes our empirical formula. This is in general how you solve any combustion problem.